making the video. So in today's video, we are going to create the first neural network in Python is the TensorFlow library. So for it, we are going to use the California housing dataset, which is available in our Google Colab itself. So let us firstly import the prerequisite library that are required for a project. So I have imported the parameter tree, and now I am importing TensorFlow. And then I am going to use the TensorFlow dot Keras dot models. I'm going to import sequential model because it is one of the most basic kind of neural network model available in around the world. But if you are aware of the mathematics of the neural net, then you can also create your own model, which is a quite simple thing. In upcoming videos, we are going to cover it. So yes, so we put it once, then I'm going. Oh, I have to write from. We have imported the sequential model. So and we have imported the else layer. So now from Scikit-learn library, we are going to import the print test split for splitting our dataset into training and testing set. Train, test, and the split. And from it, we are also going to import pre-processing, pre-processing. I'm going to import index scalar. There's a there's another basic type of a class provided by SQL for seeing our data values for the normal distribution of our data. So yes, that's the basic prerequisites I think which is not well. If another prerequisite is required, as in the video, we will later on import it. Now let us read our CSV. We got we forgot to read underscore CSV. Then from it, now I'm not able to see it. Yes. So I'm going to use here my training CSV for the California housing dataset, which is must. And let us making sure full values of it. Yes, so as we can see, there are 9 to 10 columns this dataset. So now let us define our x and y. That is our dependent feature. Dependent feature is going to be median house value. Median house. It is value for value. So the value. Now next median df dot log median house median house value and the total value because total rooms and total bedrooms are not any extra additional fee that is going to be naturally required for our model on basic stage. Yes, in higher order, it presents some important features. So currently, we are looking to create a basic environment, so it is not required. And this is an minimal because I have to eradicate the columns from the dataset. So now let us run it. Now let us do another important specific to assign access to the remaining DF. Now set the column names. As we have got the word one as we did done. Next we are getting 7. Then Now let us start to create our now let us start to reprocess our data by splitting it into training and testing set. For it, we are going to use this train test class x underscore test, comma y underscore train, y underscore test. It is quite similar to machine learning and neural net, but the difference is among the layers and the multiple calculation that we are going to have. This is and then the suitability of hospital. And yes, now we have just simply have to scale our data. Let's underscore. Let us first create an object of the statistical class and then scalar interesting and the scalar and just we are going to know it select scale. Uh, for referring to the difference of fit transform and fit. For referring to the difference of fit and fit transform, you can check out the documentation, which is a best source for understanding this difference, which will be available on the TensorFlow website. So now let we have just simply have to create our model. Model equals to sequential. Now we are going to add layers to it. I have inputted layer. I have inputted layer from model dot add trends. Once I want to go into everything on the first layer and my activation should be value and my input state is going to be of h of shape of 1 and second way output value will be nothing. I have given it because the number of features can increase or decrease in a dynamic environment, so we don't have to hard code our state. So that's why I have used this uh, was to validate the hard coding, and then we just simply have to copy paste this, and I'm going to reduce the number of the neurons by half. You can do it according to you, and there is no required for the input chip. Our student library is quite smart, and now just simply copy paste it to how many layers you want. Currently, we are developing the three hidden layers and one output layer, as we know, model.l and trends one, and our activation function will be, I think so linear function might still be good. It's still one of the basic functions. Uh, the value helps to learn the complex patterns in our dataset, and the linear just picks up out the value as it proceeds. So yes, it is done. Now let us compile our model.compile, and optimizer will be hidden, and my loss will be I want mean square error, and my metrics would be mean absolute error, mean, and just we have done it is done. Then we have to just interpret our data to it. Model.fit underscore x underscore print underscore y underscore train for training our model, I'm going to specify that h underscore I should be 32 and f should be 10 if of equals to 10. I don't require validation step currently because we always set our data set because but we always return with our data set. That is running fine. As you can see, a pressure to the model is seeing the data set. It is getting its errorless, but if the error is quite high, we can try increasing the number of records or another optimization techniques. And it has returned the object of history class, which is saved in this memory location. By using this object, you can definitely access the each pass of the thing that you have conducted. With the also system. Um, try to get its evaluation. Let's put it. No, not it. Twice its evaluation. And give twice okay. And this is our mean absolute error. And then now just try to predict it on the basis of x in the source base and the source base. This will be the value we have happened. For metrics, we can also use the artist using our model more efficiently. So let us try to do it. Scale one dot metrics import R2 underscore 4 making store y underscore prime. The value that our model has collected. So we have stored it in our variable. Now, now, let us time when I have to store y underscore prime comma modifier to test it against our y underscore 4 module not found is the end of the frame of next effects. Yes, it's around 68% adequate. It is quite less as medium have scaled values and we are not properly feature engineered our model. So later on the feature engineering we can improve the average score of our model. So that's it for today. Thank you guys for watching. You hope to see you guys in the next.